Hi, I'm Rodney, and I'm going to tell you how to find axial reduction starting from edge orientation in minimum number of moves, and how you can use this to find DRs that would be previously considered unfindable.
So let me introduce axial reduction if you're not familiar with it. Axial reduction AR is a term introduced by J. McNeil, therefore also sometimes called JZP. It refers to if you're trying to go from EO to DR, and you can do it using only R-axis domino moves. So if you take this cube in domino reduction and do a bunch of DR moves on the RL axis, what you notice is not changing is these faces aren't changing color, so no white, yellow stickers are making it onto the RL faces. And also this slice, no pieces are moving in or out of this slice. So in order to be an axial reduction, you have to have no UD stickers on these faces, and you have to have no bad edges in this M slice. Now, the cool thing is that if you know how to go from DR to HDR, you already know how to go from EO to DR using axial reduction. Because once you're in axial reduction, you're making domino moves, and so it looks just like the subsets are exactly the same as HDR. You just have to get a little used to the different recognition. So here I have got my two bad corners, bad edge, bad edge, bad edge. So this, in terms of getting to DR, I need to get this here, and I need to get this here. So this is a 2C, 2E case, and it's even easier than getting to HDR because you don't have to worry about fake HDR, you don't have to worry about parity. So this, you don't have to worry about, is this a 3C or a 4C case? Either one will work. So the shortest solution in this case is, there, U, 1, 2, 3, and I can do this either way because I don't have to worry about getting to fake HDR, and then RF2R to bring myself into domino reduction on this axis. So any EO state can be described by two numbers which we call the DRM, the DR minus, and the AR minus. So DRM is the number of corners and edges that are not in domino reduction. So in this case, it's 1, 2, 3, 4, 5, 6 corners and 1, 2 edges. So this is DRM 6C2E. And this is AR minus. And DRM can change every time you make an R or L turn. But DRM does not change when you make a U or a D turn. Similarly, AR minus changes only when you make a UD turn, not when you make an RL turn. So now if I start making U domino moves, I'm going to start to get some AR minuses, and here I have AR minus 1C, and then this is one edge, so this is 1C, 1E. So what is the general form of an EO to DR solution? Well, you're in, let's say, edge orientation on the FB axis, so the only moves available to you are DR moves on the UD axis and DR moves on the RL axis. So in general, you're going to be an alternating sequence of those. DRUD followed by DRRL, etc. And you end with DRRL because those are the only ones that change DRM. Now, it's completely general to rewrite this by saying, well, let's just group all the half turns with the R's and leave the U quarter turns on their own. So it's also fair to write any general solution like this, as DRRL sequences separated by quarter turns. So we can actually measure how far we are from domino reduction by counting these quarter turns. These quarter turns could be, I think, arbitrarily many, but it turns out that 2 is always enough, although optimal sometimes has more. But so we can characterize by the number of U quarter turns. Now, but which are the solutions that are most findable? Well, the one everyone knows how to do is the case where all these DRRLs are actually consist of only half turns. So this whole thing reduces to a DR on the UD axis, and then at the end you have one of the familiar triggers for 3C2E or 4C4E or 4C2E or 7C8E if you're familiar with that. So then you have this form where you have DRUD moves and the trigger. So these are the easiest to find, and you should definitely be familiar with those first. But we're going to see how far we can get beyond those. So if you want to use axial reduction, then you're allowing this final DR to be arbitrarily long and have different forms, and this is and it will of course look like HDR like we described. So the kind of the easiest that's like intuitively findable sub case is when like there's really only one move that sets up to axial reduction. So like two moves, so a setup and then a U, and then you're in axial reduction. So those are pretty easy to solve, but it's pretty rare to find a case that only has this two move setup to axial reduction. So we're going to try to find the next most findable and far more likely case, which is when we have a set of RL axis domino moves followed by a single quarter turn. So this is the 1QT case. 1QT case of going from EO to DR. Domino reduction, domino moves on RL, a single quarter turn on the UD axis, and then you're in axial reduction, finish like that.
So let's talk about how the DR solutions break down in terms of their findability. This is all of the sub-7 DRs broken down into those categories by corner DRM plus these kind of findability families. And you can see that learning the DR plus trigger, especially for 4C, gets you pretty far. Most of the cases, this is the biggest single case. 4C has lots of triggers. 4C4E, 4C2E, 4C6E are all triggers that are counted here in this case. But even if you add 3C2E, which everyone knows, 7C80, which many people don't, but even if you add both of those, you're still only getting to 30% coverage of the DRs. So you're finding only 30% of sub-7 DRs if you restrict yourself to this column. If you add in short setups to axial reduction, so two move setups to axial reduction, you get just another 5%. And a lot of those are coming from these 4C. So if you know how to throw in an R move to your 4C solutions, then you're probably already there anyway. But where the axial reduction is really going to pay off is if we can get to this column here, right? So this column is when I have DR moves on the RL axis plus a single U quarter turn plus more, and then I'm in axial reduction for the finish. Then I'm going to get another 20% of sub-7 DRs will become findable. And that's because now I can start to actually solve these 5C and 6C cases, which previously pretty much I think everyone just discards them.
So let's talk about what it looks like not to be in axial reduction, but to be entering axial reduction. So here are the triggers. So first of all, the requirements, if you want to be one quarter turn away from AR, of course, all the non-AR pieces have to be on the same face because you're going to make a U-turn. So the U is going to be the trigger that gets you to AR. And so all the non-AR pieces have to be on the U face. So, and which means you can only have up to 4 corners. So five ARM 5 corners is automatically 2 QT case. ARM 3 edges automatically 2 QT case. But if you have 4 or less and 2 or less edges, then you can set up a trigger. Here's what a trigger looks like for 4 bad corners. So you put them all up on the face. And the important thing is that there's some pieces that matter and there's some pieces that don't matter. So nothing on the D face matters. As long as it's not AR, it can be in DR, it can be out of DR. That's not going to matter. Also, these two pieces, if they're bad, they can be bad or good. So having a good piece here is fine. These need to be good because they're going to be on this axis after you make the use move. These need to be good. So that's what a 4 QT case, 4 corner case looks like. And then for 3 corners, you of course you still have to bring all 3 corners up to the U axis. And the 4th corner has to be in DR. It's because it can't change. If it were one of these, it would change to AR. If it were a non-DR corner, a non-DR non-AR would change to an AR corner. So so when you have three bad corners, then you set up a trigger that looks kind of like this, where again these have to be these can be good or bad. These have to be good. These have to be good. And then the three arm corners plus one in DR corner. And then if you have two, then it looks like two out of AR corners and two in DR corners. And then if you have one, it's one plus any three. So so these are examples of triggers. Now, I hope you limbered up because we're going to do some brain bending. That's what we're here for, right? So recall what we're doing here is we're making DR moves on this axis to bring some target pieces to one edge. Does that sound familiar? Yeah, it should sound familiar because it's exactly what you're doing when you're setting up 4C, 4E in a regular domino. So if I turn this on its side, then here are all the pieces that I've oriented, that I've brought to this face for the trigger. And so that's the same as setting up a DR minus 4C4E trigger. If I go like this, if I go like this, right? So if I can recognize my four target pieces and that I have them in this configuration, then I can go the same moves that I would use to solve for DR minus 4C4E, I can use to solve axial reduction. So that's what we're going to do. Now, the recognition is going to involve mapping your head into a different definition of what constitutes a bar. So when you're setting up 4C4E, you're looking for these bars, and the bars are easy to recognize because, of course, they're the only bad pieces. And in this case, there are pieces that you are paying attention to, and there are pieces that you're not paying attention to. So I don't care about whether this thing is forming a bar or not. I have to only pay attention to the pieces I'm trying to bring to this face. So let's talk about the definition of a bar when you're in setting up an axial reduction trigger. All right, so when I'm setting up the analog of a bar, setting up the AR trigger. So first thing to notice is, remember, these had to be in DR. So this has to be a white sticker. So the bar remains the bar if it's got has to have the white sticker in the middle, right? So there's a bar with a white sticker in the middle. This one has, this case has 4 AR corners. So if you have an AR sticker, 2 AR stickers plus a UD edge, that's a bar. However, now remember, in this case, there's our bar as we defined it before: UD sticker, a UD edge in between two arm corners. But remember, this one had to be in DR too for the three arm case. My fourth corner can be anything as long as it's in DR, which means it forms a pair with this one. So if I'm forming a pair with a non-arm corner, so an in AR corner, then that also constitutes a bar. So this is a bar when I'm making the analogy to 4C4E. So there's my one bar that forms another bar, and now I've set up the trigger, and that's basically that basically carries over the whole way. So again, this is an AR corner, UD edge, and then a pair. So an AR corner with a pair, that makes a bar. And then finally, of course, I can also have two. I can also have a legitimate sidebar here. So so that counts as a bar. And this is these are my two bars. And then of course the analogy here, these are the bad corners in the quote E slice, just like this one. So when I'm lining up these bars, of course, I can't put them here. I have to put them here in order to actually execute the trigger. So the bar recognition is the big thing. If you can wrap your head around, oh, this is a bar, and therefore I can solve this the same way I solved that for C4E case, then you're going to be able to put all that effort you put into learning those 4C4E cases to use for these cases too. A couple other things to keep track of. One is you have choice. You have choice of which pieces to pay attention to for the ones that are not out of AR. So I have other pieces. If I can bring another piece here, that would be a different bar that will also get me to AR. So this trigger, but I have an alternate bar. If I suppose I came here from that L move, if I do that, then I brought another corner there, so I can try that, and maybe that gives me a better AR case, like a better DR subset. So that's one thing to keep track of. You have actually many ways to form axial reduction. But the thing you must not do is turn the DRM corner number odd, right? So I'm only in axial reduction even if I have zero out of AR corners and 0 out of AR edges. I'm only able to solve it using the rest of the way if I have an even number of arm corners. So this is 1, 2, 3, 4, 5. So this is actually not in axial reduction because I have 5 bad corners. Now the DRM number changes potentially every time you make an R move, but it changes from even to odd only if you have an odd number on the face. So let's just look at here. Here I've got 4 bad corners. If I make an R move with 2 arm corners on that face, I still have an even number, so I've still got 4. But if I make it with an odd, then I'm gonna so this is 1, so there's 1 arm corner here. If I make an R move here, I'm going to change my DR corner number from even to odd. So 1, 2, 3, 4, 5. So this is what I would call fake axial reduction because the counts are right, but the parity of the corners is wrong. And I can fix that in this case because here I have another bar, right? So instead of using this bar, I'm going to use this bar, which I can bring into place with a quarter turn. So that's going to change my DR number from odd to even. Now I have 1, 2, 3, 4, and I'll be in axial reduction when I solve it that way. And look, in this case, I even got a 1 move finish. So that's what we're going to be trying to do. Let's move on to some examples. So here's the first example. This is 5C6E. So garbage DRM, you would think, but let's just check the AR setup. So I'm going to do a Z rotation and then look for bars that involve my ARM corner. So there's my ARM corner. That's not a bar. Oh, but that's a bar. So I've got a bar up here, and here's another bar ready to form. And furthermore, if I bring this onto the side face, then I will change the DRM number from 5 to something even. So my corresponding DR minus 4C4E case is here, except I can decide to set them up on either of these faces because I actually don't have any bad edges here to worry about, unlike what I would have in 4C4E. So I can do an R prime, L prime, U, and then it so happens that this sets up to a good axial reduction with a 4B2E corner subset, which so R F2R brings me to DR.
Here's a second example. It's also 5C, 5C4E in this case. So we look at the AR set of prospects. I'm going to do the rotation. Here's my two AR corners, so I'm going to need to include those. And here's a bar this one forms, and here's a bar this one forms already. So that puts me in this DR corresponding DR minus 4C4E case. This time I do have a bad edge here, so I need to bring them here. So that solution is the remove setup L prime R2U. It brings me to AR. Now check the subset. The subset is easy corners, 4C, but it's two bad edges, so that's not going to work. So what other corners do I have that form a pair that I could possibly make a bar with? Well, here's another corner that forms a pair. So what if I tried to bring these four corners to the same face? That would be this. That would be this dr minus 4c case. And that's, you can see that solution is in this case L2, F2, L prime, and that brings my two bars to the same face. And then I do a D, and this time I have a good subset. So D prime F2L brings me to DR. Here's one last example. This is 6C, 6E. And if I do the rotation and start looking for bars, here you can see I've got my two AR corners. Here's a bar, but here I have the problem that if I bring this bar to a face, like to match up with this one, I'm going to change my DR corners from even to odd. So I need to actually move both of these in order to reach axial reduction. So if I look at other pairs, I notice here there are two pairs here. So that would actually correspond to this dr minus 4c case, right? Where I've got where I can match the bars like this. So that solution is F2 L2 and then an R prime L to bring them onto this face. And so that's a 1, 2, 3, 4, 5 to axial reduction, which I don't think you could ever possibly find without using this technique, but I think it's plausibly findable. And in this case, you end up with a 1-move finish for a 6-move DR. So for a long time, I wanted to kind of formalize the process of going from EO to DR as this sequence of alternating DR moves on the two axes. And I think I've landed on something that is potentially pretty useful. What's missing is an estimate of how likely a case is to result in a sub-6 DR. The examples I picked, I knew there was a sub-6 solution in there, so just talking about findability, not about precision. But I think because you can identify those kind of weird, AR trigger pairs and the top pairs, I have a feeling that the combination of those will be pretty predictive of whether it's worth looking for these axial reductions, and maybe even predict whether it's good to NIS. I haven't spent a lot of time practicing this technique to get fast at it, but I'm not that fast anyway. I know that some of you have those 4C4E cases in your muscle memory, so if you're one of those people, spend some time with this recognition, and maybe next time you got a tough scramble, can't find any good DRMs, whip this out, see if you can cycle quickly through all the ARs of the garbage looking DRMs and pull something out. And if you do, be sure and let me know.